This is Mr. Beck Does Your Homework, Homework 22, questions 5, 6, and 7. A 4 ohm, a 12 ohm, and an 8 ohm resistor are connected in series with a 24-volt battery. So, draw a picture. I've got my battery. I've got one resistor. I've got a second resistor. I've got a third resistor. My battery is 24 volts. My first resistor is 4 ohms. My second resistor is 12 ohms. And my third resistor is 8 ohms. And I want to calculate the equivalent resistance. The equivalent resistance is going to be R total, or sometimes REQ for equivalent, and that's going to be the sum of the first resistor and the second resistor and the third resistor. So I can just add them up if they're in series. So for me, my equivalent resistance is going to be 4 plus 12 plus 8, and that will give me the equivalent resistance of the circuit. Question number 6 says, what is the current in the circuit? Well, again, this looks the same as a 24-volt battery hooked up to a single resistor with this equivalent resistance. So I know that the current in the circuit is going to be, by Ohm's law, I is V over R, my voltage of 24 divided by my equivalent resistance that I just solved for. So that will give me my current in the circuit in amps. Now it says, what is the current in each resistor? Well, if I know the current leaving the battery here, which I just solved for, I also know the current leaving the battery here. That's also the current going into the battery. That's also the current flowing down all the way. And all of this is happening at once. So I've got this circle of current going around at all places at the same time. But if I know my current here, it's going to be the same as the current here. It's going to be the same as the current here. It's going to be the same as the current here. The current is the same everywhere in that circuit, because my total leaving the battery current is going to equal my current through the first resistor, is going to equal my current through the second resistor, is going to equal my current through the third resistor. That is how it works in series. My resistances add, my currents are exactly the same everywhere in that series circuit.